We will be graphing today. We are going to do circles, mainly today. But this chapter is on conic sections. Now, since we did a section on parabolas already, we're going to actually skip that, that part. We're doing conic sections. And today, specifically, we are doing circles. And I'm going to introduce you to things kind of in a different order than your book introduces it, just because I can. But it will make our lives easier as we get towards the end of the chapter. Now, we're only doing, of the conic sections, well, what is a conic section? That's going to be the first thing. Like, what is that? Well, picture a cone. And I'm going to start slicing that cone in all sorts of different ways. Okay? So if I sliced that cone this way, okay, with a rectangle, okay, hopefully you would see that on that rectangle I would get a circle. Okay, now that my circle is pretty bad right there, but I would get a circle if I sliced that cone directly horizontally. So if I took a plane and I said, all right, plane, oh, that's not a plane, that's a circle. Okay, if I took a plane and I sliced it through, and I'm asking, well, what shape do I get? Okay, and it comes down to, depending upon which way you slice it, that if I slice it horizontally, hopefully you see that you would get a circle on that plane, right? If I did it perfectly horizontally, I would get a circle. And if I sliced it, now if I sliced it at the top, I would get just a point, right? If I just sliced it right here, boom, right at the top, I'd get a point. And if I took that horizontal plane and I kept on going up my cone, my circle gets smaller and smaller and smaller. Now, if I sliced it diagonally, horizontally but diagonal, diagonally, last class, my thing all screwed up, I would get an ellipse. I don't know how to spell ellipse. How do I spell ellipse?
There's an E on the end of this.
Just with an E? Ellipse. There. That's why I'm getting it all wrong. If I do like this, like it'd be a distorted circle. So it'd be like this. So that's an ellipse. If I went vertically, okay, so I'm going to erase this cone. If I went vertically down, so I sliced it like this, okay, hopefully you see you'd get this shape, right? If I went straight down vertically, that'd be a parabola. Now, if I did it vertically but diagonal, this one's going to be hard to picture. Hard for me to draw, anyway. Okay, but picture it like going through like this, such that it goes through both sides. Okay, so I would get this shape on this side, and then I get this shape on this side, because I cut through it twice, right? That's going to be what's called a hyperbola. Alright, so those are our conic sections, and how we get them, I'm not too concerned about that. I really want you to find the information about them. So today we're going to start with the easiest of the conic sections, the circle. And for our circle, and for all of these, we're going to have a general form, and we're going to have a work form. All right, let's start with the work form, because the work form is the one that we use to graph. And our work form for a circle is like this: x minus h squared. So it's kind of like that vertex form, right? Plus y minus k squared equals r squared. Or I want you to recognize it like this also, because when we do ellipses, this will be important. We could divide both sides by r squared, and get a 1 on the right. So either of these is fine, but the thing under x and y is our radius. So this is, what are these parts? Well, hk, much like our vertex form, it's not a vertex though, that's our center. And r, so the square root of this thing, that's our radius. Now our general form is going to look something like x squared plus ay squared plus bx plus cy equals some number. Which is important that this this thing in front of x squared and y squared are the same if it's a circle. And whenever we have general form, we need to get our general form into work form. So there's a lot of work into that. I don't know if we'll get to that today, but we'll see. Oh, we will. Alright, so what am I going to do with this thing? Let's first practice graphing. So we are going to find, this is the typical question, we're going to find the center, the radius, and graph. Okay? So, let's get all our examples down that we're going to do. Sometimes we get our undies in a bunch when it's actually an easy question, so I'll give us an easy question. So your undies don't get in a bunch. I wouldn't want you to be in pain all day. So we'll do four of them, I guess. So the third one's the easy one. All of you. Alright, before we graph these, let's go through and identify the center and radius. Okay? What's the center for the first one? 2, negative 3. Notice it switches sign, right? And that's true for all of these. What's our radius? It's not 16. So remember, this is r squared. So that means the radius is 4. How about the next one? Someone else. What's our center? -1, 4. Yep. And what's our radius? And the next one. No, Mr. King, there's nothing there. If it's not there, zeros. So 0, 0. Radius. You like my noise that is me mimicking you? And what's our radius? 5. And the last one. -2, -5. and our radius is, what's the square root of 1? I don't know. 1. Okay. Now we're going to graph them all. You have these written down so I don't have to keep on flipping back and forth?
Just the last one.
Just the last one. So we're happy. We actually answered our question. We don't have to graph all of them. If it doesn't say to graph it, then don't graph it. Unless for some reason that, like I was saying at the beginning of class, when in doubt, graph it out. Okay, so, let's see. What was our first one? What was our center? 2, -3. So 2, -3. Do you see how I got my center? There's my center. Now, how am I going to graph the circle? Now, you can use a compass, of course, but I'm going to count. What was my radius? 4. So I'm going to count right 4. I'll count up 4. I'll count left 4. And I'll count down 4. That gives me 4 points to work with. And if this is a circle, well, I'm going to connect all those points, right? Oh, look at that. That's so beautiful. That's a perfect circle. I'm such a good artist. All right, what's the center of the next one? -1, 4. So I plot my radius, and what was my center, and then what was my radius?
2.
So I count right 2, up 2, left 2, down 2. And then I graph. I connect them very neatly with a circle. And you don't have to use a compass to do these, but boy, does it make them look neat if you do. I just don't want you to draw your circles like this. This I will mark wrong. That is not a circle. It needs to at least be arguably close, right? So, such that if I showed the shape to a 3rd grader, they'd say, oh, that's a circle. If they look at it and they say, oh, that's an oval, that's an egg, then no, that is wrong. That'd be an ellipse. All right, so what was the center of the next one?
0,
0,
0.
0. So the center. And what was my radius? 5. So I count right 5. Up 5. Left 5. Down 5. And then I connect. All right. And the last one, what was our center? I'm going to erase all these while you are looking at the last one. All right, what was the center of the last one?
-2, -5.
Say louder.
-2, -5.
-2, 5?
-5.
-5.
And the radius is 1.
So up 1, down 1, left 1, right 1. Yep. Little teeny beanie. Okay. Sometimes we have trick questions. So far, nothing too difficult with circles, I don't think. But sometimes we do have some trick questions. So let's say,
What was the general problem? I didn't get the general problem.
We're about to go over a bunch of general forms because that actually ends up being the trickiest thing from today. And I'll have to come up with a bunch of equations on the top of my head, which probably will not work out nice, but that'll be very entertaining for us. Okay. We are going to graph any of these, but we are going to say, what is the center, what is the radius? I'm going to see if I have tricked you on any of these. So what's the center of the first one?
0, 0.
0, 0. And what's my radius?
6.
Square root 6. How do I graph this? You estimate. Get it as a decimal and estimate. Alright, center on the next one.
1, 3.
Yep. And what's my radius? Square root 12, but I need to simplify that down to 2 root 3. How do I graph that? Estimate it with a decimal. Alright, let's see who I suckered in on the next one. What's the center?
That's backwards. You can't do that.
Ah, I didn't get her. It's what?
It's the y needs to go after the x.
Yeah, this is backwards. Now, do I need to rewrite it? No, I don't necessarily need to rewrite it. But good catch there, Veronica. It is written backwards. So the center is not -4, -5. It is
-5, -4.
right. Okay, so that's fair game to switch it around. Get an old switcheroo. And root 2 for the radius. Okay, sometimes I'll give you the center and the radius, and then you will need to find the circle. But I think you'll be pretty easily getting that. I want to spend the rest of the time on the general form. The general form, pretty useless. Not gonna lie, worthless. That's why we want to get rid of it.
I invented them.
Yeah, someone's summoning me. Alright, so here's an example general form. Notice, I know this is a circle because the same things in front of x squared and y squared. And they're both positive. Okay, so that's how I know it's a circle. So what am I going to do? I'm going to collect x's and y's and group them together. So I'm going to write x squared minus 6x plus y squared plus 14y equals 8. That's the first thing I'm going to do. So that's step 1. Alright, step 2 is where completing the square from the beginning of the year is actually going to be used. Like we're solving quadratic equations, and quadratic formula is probably way better. But quadratic formula is not going to help us here. We need to complete the square. I remember when I was in trig class and our teacher went over this, he just wrote it up there and thought we all knew what the heck he was doing. So I'm going to try my very best not to be him and actually explain what's going on here. So I'm going to complete this square, which means I'm always adding something. I'm going to add something right here. And I'm going to complete this square, and I'm going to add something right here. And then I'm going to add both of those things to the other side, because I can't just add it to one side and not the other. Well, how do I complete the square? I want this to be factorable. But I want it to be factorable such that the terms are exactly the same. So the way I'm going to do that is b, half of b, and then square it. Hence completing the square. So half of -6 squared. Now it's always going to be adding, so that is negative, doesn't matter. Half of 6 is 3. Squared is 9. So what am I going to add here? A 9. Well, what do I have to do? I need to add that to the right-hand side as well. All right, let's take a look at this one. Half of 14 is 7, and squared is 49, so I'm going to add a 49 to there, which means I add a 49 to here. All right, so now what do I have? Well, I have x squared minus 6x plus 9 plus y squared plus 14y plus 49 equals, I add all these together. What do I get? What's 8 plus 9 plus 49?
66.
66, you said? Okay, now what I'm going to do is I'm going to factor this and factor this. So when I factor the x's, I'm going to get x minus 3 squared. Plus, when I factor the y's, I'm going to get y plus 7 squared equals 66, and then I'm done. This is the answer. And now from this answer, I know my center. What's my center? 3, negative 7. What's my radius? Root 66. That's a book. All right, so we'll do one more together. This one will be a hard one, however. A hard one, however. All right. Let's get a 40 right here. That'll be good. And I'll just make up a number right here. A 1. Sure, why not? A 1. Oh, I'm a bonobo. You know what? Let's go ahead and do it anyway. This is not a circle. Well, why isn't it a circle? Because the 5 and the 4 are, different. My x's are already collected, and my y's are already collected, but I must have a 1 in front of them. In front of x squared and y squared. And if I don't have it, then I factor so that there is. No matter how ugly it gets, I factor. So I'm going to factor this group, and I'm going to factor out a 4. And no matter how ugly it gets, now in this case it doesn't get ugly. And in the other group I factor out a 5. And I get y squared plus 8y. Okay, so do you see what I did there? All right, so half of b squared, half of b squared so that would be 4 and then 2 squared, so I'm adding a 4 right here, And over here, that's an 8 divided by 2 squared. And that is a 4. All right, so then we're going to factor that. Now, I did forget something, and this is the risk. All right? I've completed the square, but did I ever add anything to the other side? No. Okay? There should not be 1 there. And don't write this down, because I'm going to erase it. If I do this time, I actually have done it wrong. And there's a reason why. It worked out before that I could just add the same thing to both sides, but this 4 and this 5 messed that up. So I have to think, well, it's 4 times that 4, so it's actually a 16 there. And this 5 times that 16, so it's actually a 90. So now I have 4 x squared. Now I can factor this, so I'm going to factor this, so I get x plus 2 squared plus, and then I have a 5, and I can factor this thing and get y plus 4 squared equals 170. Oh boy, could I have gotten this any uglier. Alright, so this is not a circle, and since it's not a circle, I'm going to go ahead and tell you what the next step would be. So get your calculator out.
Isn't 5 times 16 80?
5 times 16, should that be an 80? Yes, you are correct. So good job. Good job. That's 80. So we get 97 instead. So 97. Good job. All right. So I have a 97 here. If it's a circle, I do want my number right there. But if it is a circle, I want my number here. But I have all these extra numbers. So this is actually an ellipse. So when I have an ellipse, I divide by that 97. Everything. Now this does not come out nice. So on the right, on this y, I'm going to have whatever 97 divided by 5 is. Like there must be a 1 there. So that's down there. And then a y plus 2 squared. So we have 97 divided by 4. Whatever that is. Okay, let's do one where it actually is a circle. I didn't mean to give us an ellipse, but I figured since I did do that, you know, why not roll with it?
So we divide by 97 and then divide by 4?
Well, I need a 1 right here, because if you take a look at your work form, right, it's x minus h squared plus y minus k squared equals r squared. When you're getting it into work form, it has to be exactly work form. Now, I have not given you the work form for an ellipse, and as it turns out, for an ellipse, you want something down here on both of these. So, what I did, you're wondering, well, how did I go from this step, this 4 over 97, right, to this? Take a look, just look. Here's what I did really quick. Okay, I multiplied top and bottom by a fourth over a fourth. Think of it as just 97 divided by 4. That's way easier. All right, let's do one that actually is a circle. All right, there. That should come out as a circle. So I'm going to collect my x terms. I'm going to run through this a little bit faster, and then I'll leave it up. I'm going to stop the recording. I'm going to leave it up for you to copy down. So we collect our terms. I'm going to factor All right, so half of b, I'm going to do this in our head, in my head. So half of 6 is 3 squared is plus 9. And half of 10 is 5 squared is plus 25. Now, what do I need to add to the right-hand side?
18.
Plus 18 and plus
50.
50. Good. So I have 2. I'm going to go ahead and factor this. So 2 times x minus 3 squared plus 2 times y plus 5 squared equals, and I add all that together. What do I get?
76.
Say louder.
76.
76, okay. And then we are going to divide all of this by 2. And 76 divided by 2 is?
38.
So, our center is 3, negative 5, and our radius is root 38. Alright, so finish copying that down. And so notice I did this, different than the ellipse.